Good morning, Year 10. Just going to continue with Algebra 5. We were factorising quadratics last time. We're going to continue factorising quadratics today. But the objective for today is to factorise 3-term quadratics. So quadratics with 3 things rather than 2, which is what we had last time. And I'll give you a little bit of a spoiler. The answers are going to be double brackets. Last time was just single brackets. This time it's going to be double brackets, and this is the harder version for factorising. Now, before we actually learn how to factorise, we have to remind ourselves how to expand brackets, double brackets anyway. So have a think about how you would expand this pair of brackets. You've got x plus 4 brackets, x plus 7. And if you did it the way that I asked you to do it, then you'd remind yourself there's a multiplication between the brackets, and you would times the first number by the second bracket and the second number by the second bracket, and have the following: x times x plus 7 and a plus 4 times x plus 7. And that would be your first line of workings. Put the time signs in. And then you guys know how to expand single brackets. We established that last time. X times x would give you x squared. X times 7 gives you 7x. 4 times x is 4x. And 4 times 7 is 28. And when you got this far, you would simplify and collect like terms. 7x and a 4x can be simplified to an 11x. And that would be it. Now, what we are going to do today is we're going to be given this answer and try and work backwards. So there should be a way to go from that final step there, backwards, then backwards again, then backwards to that double bracket expansion at the start. Okay, now if you notice, so factorising reverses these steps. Okay, now the hardest thing to come up with is this part. If you look at it, if you try and work backwards, x squared plus 11x plus 28. That 11x came from a 7x plus a 4x. And the thing is, if you had 11x, if you didn't know that was the answer, there's like infinite amount of possibilities. You could have a 9x plus a 2x, an 8x plus a 3x, a 5x plus a 6x, but it would only work if it came from a 7x and a 4x. So we have to be able to split, in this case an 11x, up into the 2 correct terms. And if we can't do that, then we can't get these right. And there is a pattern to every single one of these, which I'm going to try and show you with EG number 2. Okay, EG number 2, we have the following. I shall leave the previous one visible. So, x squared plus 5x plus 6. We want to try and work backwards, so our next step should be this, but with the 5x split up. And the 5x splits up as the following, okay? If you highlight the number in front of the x, and you highlight the number on the end, there's a pattern. And the pattern is, you try and think of 2 numbers, okay, which add up to 5x, okay, because they definitely need to add up to 5x, or add up to 5, but then their product is 6, the number on the end. So can you think of two numbers which add up to 5 and their product is 6? Now, product means times together to give you 6. Two numbers which add together to give you 5, but times together to give you 6. Now, the best thing to do is think of numbers which times together to give you 6. The obvious one is 1 and 6. But 1 and 6 don't add up to give you 5, so that's not correct. Are there any other numbers which times together to give you 6? 2 and 3? Do they add up to give you 5? Yes, they do. So that would be the pair of numbers you're looking for. And those pair of numbers is what the 5x needs to split up into. Okay, so the 5x needs to split up into x squared plus a 2x and a plus 3x plus 6. Okay, that is the key step. Splitting that middle term up into a 2x and a 3x, and the only way you can do it is if you follow the rules from above. The sum is this number and the product is this number. Okay, you need to add up to give you 5, but times together to give you 6. Okay, let's try and work backwards. And if you look at the previous one, after this, the step above was everything factorized. You almost like factorized one, you split it up into 2 halves. You factorized the first half and you factorize the second half, excuse me, to get these two brackets. So what we do is we kind of split this in half and we factorize both halves. Okay, what would this half factorize to? Well, can do this in 2 steps, x times x plus 2 times x. Think about what's common. There's an x common, and that's it. So that's x brackets x plus 2. And factorize the second half, which is a 3 times x plus a 2 times 3. What's common? 3. So that would be 3 brackets x plus 2. 3 is on the outside, x plus 2 is left over. Okay? And then let's have a look if that matches up with the reverse step. It does. If you look at that reverse step there, you had an x brackets x plus 7 and a 4 brackets x plus 7. Now we've got an x brackets x plus 2 and a 3 brackets x plus 2. Now think if you could do this last step. How do you go this last step now to the double brackets? Okay, because if you look at this one, I did first number times the second bracket, second number times the second bracket to get this. And the clue is, see that x plus 7, that was the second bracket. This x plus 2 is going to be the second bracket. Now what would be the first bracket? It would be the things left over, x and the plus 3. Because if you think about x times the second bracket, x times x plus 2, 3 times the second bracket, 3 times x plus 2. Now this works perfectly backwards now. If I gave you this to expand, every single step going in this direction would be exactly the same. Okay, so that is the way you factorize quadratics. It's the complete reverse of expanding, and this method allows you to do it in the exact reverse steps as well.